Hey guys, good to have you here again. Today we're gonna start the last two videos of our set of videos about arithmetic sequences and series. And the reason why we're gonna work with two videos is because we're gonna start with arithmetic series properly. We're gonna be using the formulas, okay? And I think that if we just do one video, it's going to be overwhelming. Okay, so what we're going to do is the first of the two videos is going to be how to use the arithmetic series formula with basic problems. And then in the second video, what we're going to incorporate are problems that require concepts that we previously learned. Okay, so it's going to be very interesting. I believe that it's going to be helpful. So please keep here, keep in tune, and let's start just now. Okay, so as I mentioned it in the introduction, today we're going to start seeing the formula of arithmetic series. And actually, there are two formulas. Okay, so the first formula, as you can see here, we're going to post here the first and second formula, both of them. Okay, what you're gonna see is that the first formula is larger than the second one. Okay, so let's start talking about the second one. In the second formula, what you're gonna see is that we only need the first term and the last term of the sequence that we're exploring. Okay, the letter S means the sum, of course. Okay, and now, if we see this, the first formula, what you're going to see is that in the first formula, we only need the first term and the common difference. So, which one are we going to use? Well, it depends. It depends on what are the elements that are provided by the problem. Okay, so let's start. I think that the best way to see this, because you are already familiar with this different notations and the meaning of the different variables. So let's start by solving problems so you can get familiarized to this. So the first problem that we have says find the sum of the arithmetic sequence, and they are giving us part of the sequence: 3, 15, 27, 39, 135 is the last of the terms. Okay, in total there are 12 terms. So with that, we already know that 135 is going to be u12. Okay, so because the last term of the sequence is given, we're going to work with the second formula. Okay, so I'm going to start by writing the information that I have. So I know that the first term, okay, is 3, and I know that the last term, which is the 12th term, is 135. And by having this, I don't need anything else. Okay, so I'm going to write the formula of the sum, or the formula of series, Sn equal n over 2 u1 plus un. Okay, so you can take a look to the formula. If you do not remember it, remember that it's going to be provided in the formula booklet, so you don't need to actually memorize. However, the best advice that I can give you is try to memorize as many formulas as possible. Why? Because that is going to help you to be more effective with the time when you are working in a test. Okay, so well, basically the formula is already written, and what I'm going to do is now I'm going to start substituting the values of the variables. Okay, so we already know that the sum is going to be the sum of 12. That S sub 12, what it means is that we're going to be adding from the first term until the 12th, including the 12th. Okay, so n is 12, u1 is 3, and un, or u12, is 135. Okay, so I'm going to input all this in my calculator. Okay, so that is going to give me 828. So in other words, for this sequence that we have in the first problem, the sum of the first 12 terms is 828. Okay, so notice that the idea of this problem is to understand how to use the formula of the arithmetic series. Okay, now let's go to the second problem. Okay, so in the second problem, I'm going to read it. It says, an arithmetic sequence is given by the general term un equals negative 121 plus 18n. Okay, and it says find the sum of the first 10 terms. And here, notice something. They are not giving us the sequence. Okay, we only have the expression that represents the sequence. But remember that this expression, which is the general expression, is like the DNA of the sequence. So in other words, even though the numbers are or the values are not written, I have the whole sequence with the formula. Okay, so what I'm gonna do is, because they are asking me for the sum of the first 10 terms, what I'm going to do is I'm going to find the first term, which is needed by the formula, and the 10th term, which is going to be the other value that I need for the formula. So that is what I'm going to do. I'm going to write first the general formula that is given here, un equals negative 121 plus 18n. And now I'm going to replace first n by 1. Okay, so 121 plus 18 times 1. Okay, so negative 121 plus 18, that is negative 103. And u10, okay, it's going to be negative 121 plus 18 times 10. Okay, I'm going to input that in the calculator. And that is 59. So notice that what I found is the first and the 10th term. And that is basically everything that I need for answering this problem with the formula. Okay, so remember that the second formula of the series is n over 2 times u1 plus un. Okay, and now what I'm going to replace is the values that I know. N is equal to 10. Okay, u1 is equal to negative 103, and u10 is equal to 59. Okay, so the only thing that I need to do, I'm gonna put the calculator here so you can see how I input the values. Okay, so here. Okay, so 10 over 2 is 5 times negative 103 plus 59. Okay, and that is negative 220. Be careful. Sometimes you're gonna get an error here. If you got an error, let me explain why possibly you got that error. Okay, so notice that in the calculators, specifically this model, the TI-84 or TI, any of the models of the TI series, notice that we have two negative keys. The first one is the one that is below the number 3. That is when we want to say that the number is negative. So for example, in this case, when I was inputting negative 103, I used that key. If I were subtracting, then I would have used this one, the key that is above the positive sign. That key is for subtracting. Okay, so that is the only clarification in the case that you got an error. Okay, and that is basically the answer for the second problem. Let's go to the last problem of this video. Okay, remember our tradition. The last problem of the video is the one that you pause. But before pausing the video, remember to click in the button that says subscribe. Please subscribe to my channel, give a like so I can continue making this kind of videos and helping you with this content. Okay, so I'm gonna be reading the problem, then remember that you're gonna pause it and then you're gonna see how to solve it. Okay, so it says an arithmetic sequence has a first term of 20 and a common difference of 13. So notice that they are giving you the first term and the common difference. Okay, there are two questions. identify which term is equal to 228, okay? And the other question is find the sum of all the terms from 20, okay, the second is 33, up to 228, okay? So pause the video and let's see if you get the answer. Okay, guys, I hope that you succeeded solving this. So I already wrote the values that are given in the problem, the first term, which is 20, the common difference, which is 13. And notice actually that for answering, in order to answer question B, we first need to answer question A. Why? Because they are asking us for the sum of all the numbers of the sequence from 20 to 228, but we do not know what is the location of that 228. So first we need to find the location of the 228, which is the n value. Okay? And if you remember, we learned how to do that, okay, in the second or third video. Okay, so what we're gonna do now is first I'm gonna find the location of this 228 in the sequence. It is in the sequence. So because they are talking about UN, I'm gonna bring the formula of the sequence of the arithmetic sequence. So in other words, I'm gonna be working with UN equals to U1 plus n minus 1 times t. Okay? And I'm going to replace UN, which is 228, U1, which is 20, okay? N is what I'm looking for, so I'm going to keep it like that. And the common difference is 13, okay? So what I'm going to be doing is I'm going to be solving this equation. So 228 equals 20 plus 13, n minus 13. And now I just need to finish solving it. So 228 minus 20 plus 13 equals 13n. 228 minus 20 plus 13, and that is 221. Okay, and now that divided by 13. Okay, so 221 divided by 13, that is 17. So we already found that the number 228 is located in the 17th position, okay? Now I'm able to find the sum, okay? So S sub 17, which is the location of this value, is going to be, remember that now we can use the second formula, but I'm going to be using the first one, okay? So the first formula, let me erase a little bit here. The first formula is Sn equals n over 2 times 2u1 plus n minus 1 times t. Okay, I'm going to be replacing. I know that n is 17. Okay, so 17 over 2 here. 2 times u1 in this problem was 20. Okay. Times 17 minus 1, which is 16, and then the common difference, which is 13. Okay. So I'm going to be just putting all this information in my calculator. Okay. So I want to multiply 17 over 2. Okay. Times 2 times 20 plus 16 times 13, and then close parentheses. Okay, and as you can see, the answer is 2108. Okay, so the sum of the first 17 numbers is 2108. I hope that you found this answer. If you got problems or if there are some things that are not clear, please write on the comments. Remember that in the link below, you're going to find all the practices and the slides that I'm sharing with you, so you can take notes and you can practice. The answers are also there. And basically, if you have any questions about the problems that you found in the practice, and you want me to solve it, please just write me, and I'm going to be making videos or answering directly if there's a simple solution. By now, what I want to tell you is that these are the basic problems about how to use the arithmetic series formula for solving basic problems. In the next video, which is going to be the last video of our series, I'm going to be solving problems that are a little bit more complex. Okay, so if you are interested in that, please keep in tune and see you in the next video. Goodbye, adios.